In this video, we're going to learn about polyatomic ions as well as when to use parentheses when we're writing formulas given a name. Okay, so a polyatomic ion is a covalently grouped or covalently bonded group of nonmetals that have a specific charge. We'll learn in the next unit that a covalent bond is a pretty strong bond and it's between two nonmetals. Okay, so we have some nonmetals that have hooked together and they have a specific charge. Okay, they always stick together and they act like just one ion. Okay, in your reference tables on page 7, there is a big list of polyatomic ions. If you notice, most of them have a negative charge. Let me zoom in a little bit so you can see better. Okay, so here we've got like nitrate, which we'll use commonly. Nitrate is nitrogen and 3 oxygens hooked up, and when it's hooked up, this minus right here means that it has a -1 charge, or 1 minus charge. Okay. Let me just give you another example. If we go down a little bit here, sulfate. Sulfate is when 4 oxygens hook up with a sulfur, and together this polyatomic has a charge of 2 minus. Okay, so the subscript is the number of oxygens or atoms in this polyatomic. The superscript or up above is the charge that it has. Okay, some of these you should have begun to memorize already, but again, you will always have them in your reference table. Okay, now if you notice, most of these are negative, so most of polyatomics are anions. However, we do have one that is a cation, and that is ammonium, which is NH4, that has a +1 charge. Now, another thing that I want you to notice about the polyatomics is their name. Okay, so if you're given the name of a compound, a simple ionic compound, the first name is just of the metal, and then the second name is of the nonmetal, and we change the ending to IDE. Okay, in this case, if you look, most of the polyatomics have different endings. They have ates, ATEs, or ites. Okay, so when you see phosphate or sulfate, you see that ending, it should trigger to you that it is a polyatomic. Okay, there are a couple of exceptions. Hydroxide is one of them, and cyanide is the other. Okay, so let's go ahead and just practice writing some basic formulas. Okay, so let me zoom out here. So if I were to have, if I wanted to write the formula for potassium phosphate, okay, again, just by the name and seeing this ATE at the ending, I should know that it is going to be potassium with a polyatomic. Okay, so when we write formulas for ionic compounds, we need to know the charges. Okay, so just like we did with the simple ionic compounds. So we look and we see potassium here in the first column, which means that it has a +1 charge. Okay, so we'll put a plus here. And then if we look up phosphate on our tables, it's a little bit hard to see here, but it is PO4 with a 3 minus charge. Okay, now remember, just like we did with the simple ionic compounds, we are going to crisscross down. So 1 comes this direction, 3 comes this direction. Okay, we drop the plus and the minus, so we end up with K3PO4. Okay, so remember, I'm going to keep that 4 there because that's what phosphate is PO4, and I don't need to write a 1 because we don't ever include 1s. Okay. Now, let's do an example where we need to use parentheses. Okay, so in this case, I am going to write the formula for the compound magnesium, let me write the name first, magnesium hydroxide. Okay, so magnesium is Mg. And if I look on the periodic table, magnesium is in column 2, so it is a +2. And then we have hydroxide, and we see here is OH with a -1. Okay, so again, we learned our method to crisscross. Okay, so what kids typically want to do here is they want to write MgOH2. Okay, this is not correct. We want two hydroxides, right? We don't want just two hydrogens. What this means is that you have two hydrogens. Okay, so we want to say that we have two hydroxides. So how we actually would write it would be Mg parentheses, we put the polyatomic in a parentheses so that we can say we want two of everything that is in the parentheses. Okay, let me give you another example. Okay, let's look at magnesium phosphate. So we know magnesium is a 2 plus from here, and up here, remember, phosphate was PO4 with a 3 minus, so we're going to crisscross. Now, if I weren't to use parentheses, this is what it would look like. It would look like magnesium 3 and then PO with 42 oxygens, right? So we need a parentheses to show that we want two phosphates, not 42 oxygens. So we would put Mg3 parentheses PO4 2. Okay? So when do we use parentheses? We use parentheses in order to indicate when we need more than one polyatomic ion. Okay, so we use parentheses when we need more than one polyatomic.